So the corrosive issue is more of a packaging and making sure it's sealed properly. And for the lithium-air battery, actually corrosion is actually the discharge process by which you generate the power. Well, I'm obviously very excited about the work we're doing right now in energy. I learned that lesson very well in the dart guns. Not only did I invent the Super Soaker water gun, but a lot of the dart guns, Nerf dart guns, are actually based on my patents. Most people don't know that. How did Super Soaker get launched, and how did I get the relationship with Hasbro? Well, let's see. I got the idea for Super Soaker in 1982, so it's been around a while. It wasn't until 1989, though, that I met some people at a company called Laramie. During those years in between, I had built several guns, had been talking to several companies, having one setback and one disappointment after another, but through all of that, kept pushing, did not give up. I persevered. By '89, I went to New York, and I was walking the hall at a trade show, a toy trade show, and I was just talking to people who were there with various toy companies, and met some people at Laramie, and told the people, hey, look, I got this toy idea. They said, fine, but we can't talk to you now. We're at the trade show. We're talking to people who buy companies to the stores, to Walmart, Toys R Us, Kmart and those folk, and we're setting up deals. I can't talk to inventors here. But our headquarters is in Philadelphia. If you're ever in the area, drop in. Would be glad to talk to you then. I said, fine. And then on my way out, he says, well, don't make a special trip. It was like, don't call us, we'll call you kind of deal. Well, I left. I was in California at the time, living in Pasadena, working at JPL, and got home. It took me about 2 weeks to build my final generation of the water gun, which was the one that had the bottle on top. This was the first time I put the bottle on top. And as soon as I got it finished, I called the guy up at Laramie headquarters. He was the vice president there, and told him, I'm going to be in your area next week. Are you available? And met with him and the president of the company, and demonstrated the gun. They went, wow. They got very excited about it, and the rest is history.
So based on that, him doing presentations here, every summer for the last 5 summers, the students go over and see the research that they're doing at Acceleron. And in fact, that's one of their most exciting site visits, because here's an African American who not only has been successful financially, but has been an unprecedented, African American inventing things that could potentially change society.
We're going to test our prototype batteries, which are lithium-air batteries, for low pressure and varying temperature. We essentially want to recreate some of the conditions the battery will face in the upper atmosphere. So it would be a cooler environment, a low pressure environment. So we tested voltage of the batteries in colder environment and under low pressure. What kind of electrical power we can provide to the rest of the platform. And then if that's not sufficient, then another group can plan accordingly. And at the maximum, which is hopefully 100,000 feet, it'll be very low temperature. Place the battery within a vacuum chamber and run electrical leads out of that chamber and monitor the voltage as the pressure drops. Every 5 minutes, we'll increase it up. We're gonna raise it up. So our pressure is now at 10, all right? Inches mercury.
I'm Becky Tom McKinnon. I am from the battery science team. We are experimenting the battery to see how it performs in the conditions of low pressure. And as of right now, we are testing the battery in increments of 5. Every 5 minutes, we increase or decrease the amount of pressure that's contained in the vacuum chamber to see if the voltage changes or fluctuates at all.
Still at 2.84. Yeah, go ahead to 15. For atmosphere. So we are attempting to test the battery in the laboratory. So to that effect, we'll test pressure or negative pressure using a vacuum chamber, and we will test low temperature conditions using a refrigeration. Well, essentially what we want is a stable battery, which puts out a constant amount of voltage. So what we found is there's initial drop in voltage, but from there, despite colder conditions or low pressure conditions, the battery will continue to put out a constant power output.
The robotics lab is really a hands-on lab. I mean, I give instructions at the beginning on what the robotics is all about and how to use the robots, but they go through all the tutorials and they themselves come up with a design, the implementation and the testing of the robots.
The LEGO Mindstorm series of kits contain hardware and software to create small, customizable, and programmable robots.
I'm from robotics, and I'm demonstrating our project right now. The main idea of this project is to open a few different vials for graphene and biomaterials, if we may, at different atmospheric pressures. Okay, this right here is what's called the NXT, or the brick. In layman terms, this is the computer for the robot. We upload a program from our laptops or desktop computers into the hard drive of this. We hit a button, and based upon what program we've selected is how it's going to work.
This team was given the specifications needed by the sustainability and graphene teams.
Basically what we do is we test the robot after it's been built by the building team and programmed by the programming team, and we test its function to see if it does everything accurately. If not, we make a change log and tell the programming group what they need to do to change it to make it better.
When we attach the atmospheric pressure sensor, it will read a different temperature, and then it will dictate when the robot moves and screws the capsule and puts it back on. So this design is a lot simpler. It's not as heavy, though it was difficult to build, I think it'll be a better fit for what we needed to do. This is around almost 4 pounds at this point. This has been a very fun experience, and I can't wait to continue it.
Hi everybody, my name is Duminder Samarakon, PhD candidate in Clark Atlanta University. I'm one of the TA for graphene team, Research Tech. So here my team gonna present our objectives and what we'll be doing in next few weeks. Our main objective is to design a chemical sensor to detect atmospheric chemicals using graphene as a sample.
Good afternoon, welcome to the laboratory. I'm William Slater. I'm working with the graphene team on the HARP project. Now first I'd like to talk about what graphene is. Graphene is a thick sheet of bonded carbon atoms that is often derived from graphite, hence the name. Graphene is a metallic yet somehow two-dimensional structure that is flexible, invisible to the naked eye, elastic, scalable, corrosion-resistant, electrically conductive, thermally conductive, and plasmonic. Its electrical properties carry electrons as swiftly as 1/100th the speed of light, and its temperature conductivity is 12 times that of copper. Graphene has a number of applications. It can be used in medicine for bandages. It can even be used in tattoo making. To continue on this point, my group is going to use graphene to make a sensor, and to elaborate on that point, I will introduce my colleague.
We are the graphene team, and during this experiment, we will be figuring out what chemicals will be attached to graphene in the ground level as well as in the atmosphere. So, in this experiment, we will be using the substrate, like you already stated, silicon dioxide. With this substrate, we will be add drops of the graphene mixed with water as well as ethanol. Thank you. And we'll be using the pipette. And as we add drops to the silicon dioxide, we have to let it dry. By letting it dry, we will then be able to measure the graphene with the FDIR as well as the Raman spectroscope to measure what chemicals in the ground and atmosphere that will be attached to the graphene.
I've been with termites now for the past 7 or 8 years. That's the long answer. The short answer is that it's so little known about termites. That's what intrigues me. With the other social insects, we know quite a bit about, ants and bees. But termites, still very little is known. And most psychologists study human behavior, but there are several psychologists that study other organisms' behavior. And I just study insect behavior. First day of class, I say, and I tell my lab assistants when they first come to the laboratory, I say, close your eyes.
Okay, visualize the word
and
laboratory.
visualize the word laboratory.
Visualize the word laboratory.
And then I said, okay, you got the word
Now,
laboratory visualized.
what do the first 5
then
letters of
just look
laboratory
at the
spell?
first 5 letters. What does
What
it spell?
word do you see?
And then it hits it. It spells
Label.
label.
You open up your
We're
eyes.
looking at how termites convert cellulose, which is in wood, to a sugar, and the sugar can be used for ethanol. And ethanol is used with gasoline, you know. Then we go to a place called the Atlanta Outdoor Activity Center, which is 2 miles away from Morehouse's campus, and it's a forest within the city. And it was really designed to expose, especially children, but also adults, to the forest who live in an urban setting. So we have a good relationship with them. I've had a good relationship with them for a long time, so they let us set traps out there because it's a forest. I've been associated with the Atlanta Outdoor Activity Center, OAC, for probably about 20 years, 25 years. In fact, I was on the board at one time. This is a great place for teaching, but also I use it to catch termites. We set up traps here so that we can get termites for our research. Now, why did I take students out there? I think it's good for students, you know, rather than come in the lab and they see these termites, for them to actually go and see the termites in their natural environment.
My name is Judea Levitt. I'm with the Race to the Top group, which is a rising senior group for Clayton County Public Schools. Right now we're looking for termites, and unfortunately I haven't found none.
My name is Derek Witherspoon. For the end of the day,
Yeah?
I'm gonna find some termites.
Hey, hold it right there. Let me see.
It's a good amount.
We don't have that's the last bucket.
This?
Found by Derek.
Found about
You just
5.
gotta dig a little bit.
It's not what?
No, it's not a lot.
It was.
They were, they just ran away.
There go one. Maybe you all have to dig deeper. They went down, huh?
My name is Derek A. Witherspoon, the
Which
first,
one
not the
was
last.
this one, right?
And there are some termites right here. I don't know what happened. They're getting smarter, they're evolving. I keep trying to tell everybody, but they're not listening.
We can't take any
they're
more.
here.
It's good to get out of the laboratory and to be out in the sun. Now, sometimes it's hot and you got to fight up, especially with outdoor activity center. We had to put on bug spray. And,
Well, they like to be in moist
snakes
places,
there.
under rocks and logs. Let's see, this is...
and spiders and other kind of stuff, which the students, some of them freak out when they first go there. Even though they're not afraid of insects, but to go into the woods where it's not sterile like a laboratory freaks them out, but they all tend to enjoy it.
Okay, let's move on.
In an article published in the American Society for Engineering Education's annual conference and exposition, the authors demonstrated that hands-on experience with the balloon launch process improves student scientific learning, motivation, and thinking skills. We have modified this curriculum and created a comprehensive experience suitable for freshman science majors.
What you do is you lift logs up carefully because subterranean termites live deep in the ground, but they come up to the wood and eat in the wood and then go back down. So that's how they, you know.
We want to roll this back, but where's the trap at?
Right here.
Where I put it.
Right here? Okay.
Point at it, right here.
Okay, so we need to put the log over it, but then put the flag on the other side.
Okay.
Chuck Taylor's.
Oh, he keeps doing
Not
that.
again!
You know, for me, gym shoes, I know how young people are, but I told them we were going out in the forest. So I thought they, you know, most of them had more than one pair of gym shoes. I thought they wear their raggedy, but young people don't have raggedy shoes. They all clean. So. And they lifted it up and somebody said, termites, termites. And
We need a net. We got some termites.
A lot of them.
A lot of them. Okay,
right.
and try to break it.
All right, here we go.
Put on somebody's back. Who gonna hold the bottle?
Hey, get that. Whoa.
This, yeah. Pick that up and put it in.
Yes.
Let's go.
Are these termites? Are you sure?
Yeah, they look like termites.
Wait a minute, let me look at it.
No,
Wait a minute.
Maggots.
I'm about to say, they don't
These ain't nothing but roaches.
I got so happy too.
went and looked, I said, those are ants.
Those are ants. Those are things like maggots or larvae.
You have disappointed me for the last time.
John Alexander, and I thought I just found termites, but it turns out it wasn't termites. It was more larvae and maggots, unfortunately. They look really similar, but they are different.
He might have been hallucinating.
All they saw was these white things moving around, but if they had looked close, they would have saw an ant under it moving. And I said, those are ants. And they said, ants? And I said, look at it closely. And what's really cool about this HARP is the students learn how to work as a team, but then they got to learn how to work with other teams. I can remember where one of the issues we're going to have is keeping the termites alive when they're going up in space, and one is to keep them warm. And the team that's supposed to be dealing with that said they couldn't be done. And I told my students, I said, it's got to be done. So when the team came back in, I sat back and just watched, and they said, look, this got to be done. You got to figure it out. We'll give you some suggestions, but you figure it out. And I thought that was really cool.
So essentially the termite team needed two things. They need lighting to actually record the behavior of the termites during the experiment, and they also need to be heated to continue their natural behavior. So we were able to provide the lighting aspect, but currently we don't have enough voltage to provide the heating element for the termites. So hopefully another solution will be found with that.
My name is Chandler Brown, and I'm with the termite crew. Today I'm going to be talking with Jalen. He's with the design team. We had a few issues that we needed to express. Three issues in particular. One issue is the major issue of temperature. If the termites aren't kept at the right temperature, our whole experiment won't work, because if it's too cold, they won't move. If it's really, really, really cold, they'll die. And there's no way we can track their movement or anything if they're dead. So you remember how there was an issue with temperature? Yep. So we talked about it and everything, and that is a major issue that we need to be fixed. That it has to be fixed. So a suggestion is like a heating element, like a pad or something, heating pad. It could go either on the bottom.
Type of atmosphere though.
No, they have to be warm enough to function, because if they're too cold, they won't move. If it's really too cold, they'll die. So that'll cancel out our whole entire experiment. They can move comfortably at temperatures of 50 degrees Fahrenheit.
But if they don't figure out a way how to heat this, the whole termite experiment is just a wash.
Design changes occur all the time, because what you got initially gets changed. In this particular case we had with the termites, we did not realize we might have to heat them. We felt like we could just insulate them. But that brought another restriction. If we insulate them and then we are trying to video them, we have to have light in our enclosure. So we need to come up with a way of getting light in. And so we went to the battery technology team that has a battery that it's experimental, but it could be used to provide the lighting load that we need. And so we tried to work with them to get them to power some LEDs that would allow our video camera to work inside an insulated enclosure. So ask them to try that. That's the heating element that we need to go underneath our termites.
Hello, I'm William Dula. I'm with the Design, Recovery, and Launch team, and I'm the liaison